All right, for number 9, we're given a table that talks about what percentage of steel cans were recycled over a certain amount of years. So the first thing we got to look at is this chart here and understand what it means. So we're given our x's and our y's. It tells us which one is which here. And in it, it says since 1990. So x equals 0 at 1990. And then it kind of gives you an example. X equals 3 corresponds to 1993. So what we have here is 1990. 1992, 1994, 1996, 1998, and 1999. Okay, and this gives us the percentage of cans that were recycled that year. Okay, so use the graphing calculator to model the data with the quadratic function. So we go over to our calculator, and we have to go to Stat, then hit Enter. And I already entered these, so in our L1 column, we put our x values, 0, 2, 4, 6, 8, 9. And then in our L2 column, we put our y values, 25, 40, 52, 58, 56, 58. Okay, so then we got to hit Stat again. This time we go over to Calculate and down to Quadratic Regression. Okay, it takes to the home screen, hit Enter, and that's going to give us our ABC. So the model that we're going to use is y equals negative 0.62 x squared plus 9.10x plus 24.87. Okay, so that's going to be the function that we're going to use. Now we're going to scroll down here a little bit. It says graph the data and the quadratic function. So we got to graph a couple things here. The first one's going to be the data. Okay, so you can label these however you want. You can go 0, 2, 4, 6, 8, 10, 12, etc. And then up the sides, probably go by 5s or 10s. We'll go by 10s to save some time here. 10, 20, 30, 40, 50, 60, 70. Okay, so this graph isn't going to look great, but you can label these. You can just go 1 on the sides and 5 up to make it a little bit easier to read. And then we're going to look at the zeros. So we should have started with 0 here. So I'm going to redo these real quick. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so we got 0, 25. So we got 0, 25 right there. And then we got 2 and 40. So 2 and 40. We have 4 and 52. 4 and 52, so just above the 50 there. 6 and 58. For some reason, my 40 got lost in there. 8 and 56. I don't know why all these are disappearing. I apologize for that. Uh, 9 and 58. Okay, so you're going to graph your points first. And then next, you're going to graph the equation. So it's going to look something along these lines. Okay, so it's not going to be exact. It may not hit every point. You don't want straight lines because remember, we're graphing a parabola. Next, it says use the graph or the equation. So we're not looking at the chart anymore. Graph or equation to estimate the percentage of cans recycled in 1998. So 1998 would be 8 years after 1990. So we'd have x equals 8. And you can go back up and you can look in your chart and you have 1998 and it says 56. But we're not looking at the chart anymore. We're looking at either the graph or the equation. Since the graph isn't exact, I would probably use your equation here. So you're going to do negative 0.62 8 squared plus 9.10 times 8 plus 24.87. And again, you can plug all that into your calculator. Just make sure you use everything right, and we get 58%. So right around 58, which is a little bit different than what we got up here. So it was 56. So this just kind of goes to show that just because we give an equation doesn't mean it's going to be exact every time. It's a good estimation that we should use. Next, would you use the quadratic function to predict the percentage of cans recycled in 2005? So we can use it. It's asking, should we use it? Should we use that data? So we're going to do negative 0.62, and this was 15 years after. So 15 squared plus 9.10 times 15 plus 24.87. Okay, so we plug all that in there, and we plug it into the calculator, and we end up with 22. So that tells us that 22% of the cans were recycled that year. Now, would you use that quadratic function? So thinking in a real world situation here, you probably wouldn't, okay, because recycling wouldn't drop that much. Okay, so we know that recycling wouldn't drop significantly. Okay, because you're saying that over time, eventually we're going to get to the point where we start doing negative recycling. So somewhere it's just going to top off and keep going. But with the data that we're given and the domain that we use and the range, okay, it comes out to be 22. So just make sure you give an explanation of why or why not you would use or not use that data.